welcome everyone. My name is Dwayne Tennant. I am a professor, a geotechnical professor at the University of British Columbia on the beautiful Okanagan campus. And Aaron?
And I'm Aaron Hahn. I'm out of Lake Country and I work with Interior Dams, an engineering firm.
The biggest focus for this webinar is dealing with vegetation and animals. Two things that tend to be a pretty common occurrence for owners of small earth dams in this province. So before we get really going, just to acknowledge that these webinars are provided as as an initiative from the governments of BC and Canada and the Canadian Agricultural Partnership. We've been quite, Aaron and I spent a lot of time trying to put the slides together for these two webinars. A lot of them are our own images and own photographs, but we also take slides and photographs from various sources. We try to curate the very best sources, and we're not necessarily acknowledging those sources on the actual slides, but there they are. There's the sources there. And again, thanks to our partners down below that made this webinar possible. This is just disclaimer. I and Aaron, we don't work for the provincial government. So although the BC is committed to maintaining and improving dam safety, opinions that are expressed here, those are our opinions, not necessarily those of the governments of Canada or British Columbia. And as we said a few minutes ago, we are recording this webinar for possible inclusion on the BC Dam Safety website. So what are we going to cover today? We start off with a brief reminder of the dam safety regulations in place in this province. And we focus on the dam consequence classifications, and link to that, how often should you be doing your surveillance and inspection. And then we were also going to very quickly go over a review of typical dam features and typical deficiencies that you want to be watching for. If you're really interested in a more comprehensive overview of those topics, we guide you to our webinar from last year, which is now posted on the BC Dam Safety website. So these topics are covered in a bit more detail in the old webinar materials. So for today, really we're going to spend a bit more time focusing on inspection and management of vegetation, and inspection and management of sort of animal damage to your dams. So things to watch for, and then strategies and best practices for repairing and maintaining your dams. And of course, the focus is on really the smaller dams, and typically dams that have, they're made out of soil, earthen dams. We're not really dealing with concrete structures in this webinar. So I'll leave this to Aaron to just give us a quick overview of the regulations.
All right, and like Dwayne said, this is covered in the last webinars. I think webinar 1 in that link that I sent you from 2021, we spend a lot more time on this. The regulations is kind of the tougher parts to get through, and we really want to focus on some real rules of thumb and leave you with some practical guidance to take home. So we're going to run through this as quickly as we can. So the dam safety regulation, I think everyone's aware that this exists. I think it first was posted in 2001, or maybe it's 2000, don't quote me on that, but this is the 2016 update. So dam safety regulation, it sets out requirements, best practices, and really the best practices are minimum requirements the dam safety regulation provides. And so it has minimum frequencies for maintenance, surveillance, and also has some requirements for operation maintenance, surveillance manuals, dam emergency planning, and so on. And that's what it looks like there. So the dam safety regulation, really, it has almost tiered level of minimum requirements. So it's really based on what is the potential consequences of your dam failing. So the bigger your dam, and the more stuff that's downstream, or the more the loss of that water may impact people, the minimum requirements increases. So if you have a highway down below, we know a lot about highways of late. If you blow out a highway, it has huge impacts, and therefore they bump up the minimum requirements. So this is kind of a summary of the table right in the dam safety regulation, and it gives you some idea of what those consequences are. And then as you go over to the left side of the table, if you can see my mouse here, that would end up being your consequence. So the red line is kind of a line where all of a sudden there are more requirements. So we'll get into that a little bit more.
But all dam owners need to know that they have to review their dam every year to see
Yes.
if any changes have occurred.
Yeah, so annually we're required as dam owners to just review that consequence classification and make a note of it. So it doesn't have to be a dam break, assessment or study. We just need to look at it. Has anything changed? Is there new development? So on. And make a note of it. So, and this generally doesn't apply to minor dams. They're not regulated, and it doesn't apply to dugouts, but same best practices. So responsibility for an owner is to keep it safe. You have to maintain it. So an owner must inspect, maintain, and repair. So the thing is, that is not only just a minimum requirement for you, it's also a right. So as a water license holder, you need to realize that you can go ahead and maintain your dam. There are quite a few things under maintenance that may, there's a gray area between maintenance and repair, but there are quite a few things you can go ahead and do. And we're going to be talking a lot about what is a notification, when should you do a notification, when you should do an approval, and things that need permits. But also we're going to show you some rules of thumb of stuff you could just go ahead and do. So here we go. Oh yeah, and I just wanted to mention, today we're really focusing on inspection, maintenance, and repair. And we're going to talk a lot more about instrumentation monitoring. I'm going to keep going here. So an owner of a dam must do the following. So conduct regular surveillance. So depending on the consequence, again, the number and frequency of surveillance inspections that you have to do in a year will change. So it might be weekly, might be monthly or quarterly that you do a surveillance, typically a formal inspection, which most often is done by the owner, but sometimes they hire a third party, an engineer or something, to do it on your behalf. That usually needs to be done once a year, and for extreme consequence, it can be twice a year. The important thing is all these things are done and recorded. So, and here's the frequency I just talked about. Site surveillance, can be weekly, monthly, quarterly. Formal inspection, typically annually. So, and I want to point out that an OMS manual, an operation maintenance surveillance manual, it's only required for higher consequence dams, for significant up to extreme. So it doesn't apply to low, and it doesn't apply to dugouts or minor dams that aren't in the regulation. But if you're in a place where your dam doesn't impound water, maybe it's in the Alpine, you can't inspect under 10 feet of snowpack, and maybe there's no risk. So there's no reason to inspect it or surveillance it weekly, for example, because there's very limited risk there. But at freshet, in those types of dams, you actually might want to be there multiple times in certain weeks of the year. So you can deviate from these. These are the minimums unless you have made a plan that's been accepted by your regulator. Okay, so moving on, there's an example of an OMS manual. You can find that right on the dam safety link. It's really simple. I think this one's only 4 or 5 pages, but it gives you an idea of what's the minimum requirements for an OMS manual. And obviously they get quite a bit more comprehensive as your dam gets larger. Okay, so surveillance planning, we just talked about this. It's defined by either the regulation. If you don't have an OMS manual, you're required to do that minimum requirements, or your OMS. And really access and other things can really dictate what's the best frequency. And also unusual events. If you have a seismic event, major flood, maybe it's freshet, which is typical annual conditions, but they're still, unusual, or they may deviate from the norm in your particular year. You will want to increase or have some post maybe seismic surveillance.
Or after an atmospheric river.
Yes, or after one of those. Or maybe during, right? Or before, you know it's coming, you go up there, make sure your spillway doesn't have a beaver dam in it.
Exactly. That's be proactive, yes.
Right. And make notes of it. So we just keep hammering that home. There's lots of guidance documents out there that goes over these same points we're going to do focus on animals and vegetation, but here they are. There's a nice new pocket guidebook. It's a lot like the FERC one. But it's got a lot of nice little figures and things to look for if you're not aware of what they might look like in certain cracking or differential settlement, things like that we don't really cover today.
And they're digitally available. You just download them.
That's right, exactly. And I think you could probably get a hard copy from your DSO if you're ever close by their office, because I know they do hand those out for free. So activities near dam. So we want to get into more of the prescriptive. What can you do? What shouldn't you do? So an alteration or improvement to or replacement of all or part of a dam must be authorized. So it has to be authorized under the Act. That's the Water Sustainability Act, which the dam safety regulation is, a piece of. It's under that Act. So when you apply to do work on your dam, you submit it to your dam safety officer, you have approval under the Water Sustainability Act. But also with your water license, it's a license through the Water Sustainability Act. You have certain rights to maintain and do things under that Water Sustainability Act. So there are some other maybe not conflicting, but complementary or overlapping regulations out there. We're going to talk about the Wildlife Act as well as the Fisheries Act. We're going to touch on those. So we're going to talk about a lot of this more as we go, and also emergencies. If an emergency happens, or you're given an order to respond, you also have approval to do work. Okay, so we're going to keep going. Dwayne, you go ahead. You can take these. Yes.
Okay, so I'm just going to quickly review. We don't know the level of knowledge for the participants here today, so just a quick review of terminology that may be used in today's webinar as well as the one in Wednesday. We're dealing with embankment dams, earthen dams, as the topic for this series of webinars. And we use the word crest of dam and a cutoff trench. Many of our dams will have a cutoff trench to upstream and downstream slopes. We may have riprap, big chunks of rock on the upstream face to prevent from wave erosion. The height of the dam, and the height of the dam links back to some of the regulations, because whether your dam falls under the regulations or not will be dictated by the height of the dam, and it's from the lowest downstream portion of the dam to the crest elevation. So that's your definition of your height. So you got to go from the lowest downstream portion up to the crest. And hopefully your dam crest is pretty much at a constant elevation. You may have a dip someplace if your crest has a kind of a built-in spillway or an emergency spillway on your dam. Just again, another kind of pictorial view of that. The terminology right and left for the abutments is always with reference to looking downstream, looking in the direction that the water flows. We have terms called the abutment or the groin area, where the dam kind of meets the valley wall. Many of our dams will have a low-level outlet in which we use to release water for irrigation or environmental needs. And many of our dams will also have a spillway. So you may have a combination of a spillway and a low-level outlet. And some dams even have a third spillway, like an emergency spillway. So these are various elements that are common in dams. And so if you think about your dam, how could it fail? Well, if you look at the 10,000-foot view of dam failure modes, we see dams that can actually fail on a sunny day. So a sunny day failure is one where typically you don't have overtopping occurring. The dam is just sitting there and it suddenly decides to fail. And that failure mode is likely to be caused by the gradual internal erosion, or the term piping, that will cause that dam to fail. So that's a mechanism that we're going to talk a little bit more about today. Of course, when you have an extreme inflow, such as an atmospheric river comes in and really fills your watershed up with water, and suddenly your dam is overtopped, that can cause a failure and breaching of that dam. Some dams can handle a little bit of overtopping, and we'll talk about vegetation and its role in helping preserve and protect a dam if you happen to have overtopping. But that's a pretty obvious failure mode when the water goes over the dam and washes it out. That'll be linked to typically an extreme inflow event. And these extreme inflow events could be something caused by, I don't know, like a beaver dam upstream that it fails, and then all of a sudden that pond of water comes into your dam. So it doesn't necessarily have to be triggered by a extreme precipitation or a snow melt event. And when your dam fails, it's usually not just one cause. It's usually a chain of events, a sequence of events that lead to the breaching or failure of your dam, and it's not a single event. And that's important because we use our inspection. The most powerful tools you have for inspection are your eyes linked to your brain and an understanding of the various mechanisms that could cause failure of your dam. And we're looking for weak links in that chain. And if we can find them, we can be proactive and we can make those repairs, and then we prevent our dam from failing. So that's really the role of inspection: find those weak links in a timely manner, implement the repairs, and protect your dam. So some of the things to watch for, and again, there's a whole 1 hour or 2 hours of video that we did a year ago focusing on all of these elements, and today we're going to really focus on the vegetation and animal aspects only. So we're looking for presence of vegetation and animals and animal burrows, but we're always worried about things like piping, where you have internal erosion or cracking or slumping and landslides, or suddenly we're getting maybe excess seepage that didn't occur before starting to occur, or a boil. We'll see some examples of boils in our workshops today and on Wednesday. So those are things you're always looking for: distress and damage, because they could be indicators of things happening internally that might be very important.
Yeah, Dwayne, I'd say too, this slide's good, that even though just the highlighted red things are what we're talking about today, they often cause or are related to some of the other modes of failure. So we're going to be talking about and going through some case studies in just a little bit.
Yeah, because it's a link in a chain, and the rodent activity could lead to excess seepage, which could lead to piping. So there's always a domino effect, and we want to look at every link in our chain of various things that could cause failure to occur. So today we're going to focus on vegetation and animal management, settlement, slumping, seepage, and surface erosion could all be related to animals and vegetation as well. So we have to be watching for these things. And when you see them, you should actually be indicating on some document what you found and when you found it. Grab a couple of photographs and start to create a paper trail of those deficiencies. So what I'm going to do, because we have now about 33 people logged in, let's get a sense for what type of issues you guys deal with, and I'll do that by asking these 3 questions in a poll. So floating vegetation in a spillway or water conveyance works. So we got over 50% of the people that responded say they're dealing with it sometimes, and it's only 19% that never deal with floating vegetation as being an issue. Tree roots. But the question was a bit specific. So tree roots impacting drains or outlet works or the dam embankment. So I could have maybe split that one apart a bit because we probably have tree roots affecting everybody's dam embankment. And maybe we can explore that a bit more as we get into the tree root problem, because it seems like everybody's got tree roots because everybody has trees on their dams. Vegetation restricting inspection. And so we're seeing, there's 2/3 of the people are dealing with vegetation that actually impedes the ability for you to either physically access parts of your dam or to visually inspect the dam. And that's a very common issue, and we'll be addressing that in this workshop. Good. Any questions, any comments there, Aaron?
No, I had some questions about log booms. Quick note, they were curious, do you need a notification or approval to fix them? And I said no, right? If you're not changing the design, you can put new logs on or new linkages. Wanted to say too, that last question is vegetation doesn't always obscure your inspection. It actually aids it sometimes. So we're going to talk about how vegetation, you can use it to your advantage.
So just one little example. So here's a small dam that breached back in 2015, and this came out of the 2014-15 BC Dam Safety Program annual report. There's an annual report of all the dams that fail or come close to failing every year in this province. So don't assume that dam failure is a rare event. Well, it is a relatively rare event, but there are a handful every year that are coming close to failing or have failed. Unfortunately, the consequences of these failures tends to be pretty small. And our goal is to make sure that they get even smaller. That's the goal of these webinars. But here's the language that was in that report. So the failure was due to inadequate spillway size compounded by debris from beaver activity. So you got animals and you got vegetation, because the debris is probably vegetation. We got instabilities to the berm from animal activity. It didn't say what kind of animal activity, but it's likely to be burrows. And then there's overgrown, well, as you can see in the photograph, overgrown vegetation and internal erosion. The failure was caused by a combination of all these things, but animals and vegetation were key factors. What I have now is a set of slides for just examples of things to watch for. But as a sort of a preamble to that, control of your vegetation is an important part of dam management and dam maintenance. It's something we have to do. It's just really quite important. And a properly maintained vegetation can help prevent erosion. For example, if you have an overtopping event, that vegetation is beneficial, and we want to maintain that vegetation. Uncontrolled growth, however, of vegetation can cause damage to your embankments, and if you have any concrete structures, they can cause damage to those structures. And it makes inspection and dam access difficult. So that bottom stuff in red, inspection and dam access, is probably the more common thing we're dealing with when we're dealing with vegetation. And so there are guidance out there as to what are the impacts of vegetation on dams, because across North America, people have been dealing with this and they know it's an issue. Reduces spillway capacity. And that may be both vegetation growing in the spillway or sticks and logs that have got trapped in the spillway. Limits access for inspection and maintenance, obscures the surface, and limits visual inspection. The roots can block internal drains if you happen to have them in your embankment. Can provide habitat and attract animals to take up home in your embankment.
And that's a big one there. Yeah.
Yeah,
that's a big one, the attraction, right?
And if a tree gets big and dies, or the tree gets big and you say, oh, it's too big, and you cut it off, well, those over time, the roots from that tree will decay and they may create seepage paths through your embankment. So your management of the vegetation was a little bit not proactive, and you allow the trees to get too big, you chop it off, you're feeling really good about yourself. 25 years later, maybe that's a problem because everything's rotted out and now it's a seepage path through your dam. If you get big trees with big root balls and you know, climate change, we're getting more and more intense winds. These things can blow over and cause some damage to your dam. We already spoke about concrete walls and structures. So vegetation can do all these things to your dam. So now let's go through some examples of photographs. And so here's a photograph of a dam, and you know, maybe you're not so concerned about this shrub here, but it's probably getting too big. Of course, all the ones in the background are on the downstream face of your dam. They're all too big. They shouldn't be there. So, you know, way too big. So this thing here has not been properly maintained. There's a spillway for this whole structure and a low-level outlet. You don't want them to get this big. Another example, this is probably more locally, upstream face. You know, if it's down near the water and it's a tree species that likes to have water and you're nice and hot and dry, and in the Okanagan, for example, these things can take off and grow very quickly. So you have to be on them. You got to be very vigorous about managing these trees. Talked about root balls and blowovers. So if your trees get big and they blow over, and this is a very small embankment dam, it creates a bit of a hole here and it reduces the seepage pathway through your embankment. And that could lead to failure. And there's an example coming up right here of where that's exactly what happened. So it's hard to see that there is a dam here because it's all covered in these really huge trees. A tree blew over right here, and the big root ball essentially lowered the crest of that dam. And you can see where the water, the more typical water level, then occasionally the water gets up higher. The water then was able to flow through that void caused by the root ball and cut down through the dam and through the roots from all the trees. So we have to be, you know, we just don't want our trees to get big. Just for curiosity, you're probably aware of the Orville Dam. It's the highest dam in the US. And a number of years ago, it was overtopping, and but the biggest issue is they were putting a lot of water through their spillway, and their spillway blew out. They lost their spillway. As a forensic post-mortem analysis, they were trying to understand, why did the spillway itself fail? Why did big pieces of concrete all get ripped off? And they were looking at the impact of vegetation and the impact of vegetation on the drains. So this is part of that spillway. The gates are up there. There's lots of drains along the sides and underneath the spillway to reduce water pressure. And so they start digging out and following roots to see if these roots from these trees are finding their way into the drains and blocking the drainage. And that's what they found through that process. So some of these trees, which are quite far away from the spillway, their roots are pretty smart. They know where water is. Once they find the water in these drains, they occupy the drains and grow in these drains and block them off. So that's some examples of roots. Here's another example. We tossed it in as vegetation. So floating peat mats. A lot of our dams we're blocking maybe a small stream that flowed through a boggy area, and we now created a reservoir. But the organic material that was in the boggy area now pops up as a floating peat mat. So this photograph shows the same peat mat, from one an aerial view and one down from the ground. And this peat mat's been folded up in the wind and kind of got anchored into the shoreline. It still has, you can't tell because it's fall, but there are shrubs that are growing on this peat mat plus the grasses. So it's a little island of vegetation floating around. Well, the wind can change direction, and this thing could blow towards your spillway, for example, block your spillway. I suppose here's the shaft for a low-level outlet on this dam. If it were to blow along and kind of grind against that shaft, we could cause some damage to the low-level outlet. So this is one thing to be aware of, and it's not as if they're unique occurrence. Another dam. So these are all photographs that Aaron and I have taken. Here's another dam, and you can see here's the peat mats, and this is actually another one over here, along with some other debris that's floated in on this small dam. Yeah, and here's a third example. giving you a sense of scale. So this is 1 meter. And so these peat mats could be easily more than a meter thick in terms of the organic material. And they, as a reservoir comes up at a high elevation, the thing will pop up and float, and the wind will push it around, and it may find its way to your spillway.
And that's an ideal time to deal with them, right? Because you can get to them.
Yeah.
That one was really close to that last dam photo where you could just walk a piece of equipment along the shore, right?
Yeah, walk it along and grab it and pull it off. At this site here, they've been pulling off peat mats numerous times as they keep popping up and floating in. So they bring an excavator in and they just excavate it out, particularly when the reservoirs are a bit lower down. So that's their strategy for dealing with the peat mats. Their strategy is remove them. And some people are quite excited to get access to this material for gardening purposes, other stuff. So you could turn it into a resource and maybe make some money off of it. Of course, there are other things that can block your spillway. So this is a kind of a poor spillway because it's a corrugated steel pipe, a culvert. Of course, we got somebody's, I don't know, raft or low budget dock and other debris that's floated in and started to block it off. So we want to be aware of vegetation and debris that can block off spillways. Here's a situation where we have a low-level kind of outlet with a valve here, and this is kind of concrete under the water, which is out here. And so if you get vegetation and debris that comes in, either by itself, by floating in and filling up your inlet, or I don't know, maybe a beaver decides to stuff it in there, regardless of how it gets there, it could cause you some problems. So, these guys are quite concerned, of course. So you can see got rescue here. It's an emergency situation because the dam was overtopping. They've already removed a lot of vegetation from this area, and they're still working to clean this thing out and get the low-level outlet working so the dam doesn't overtop. But looking at that photograph of the dam, these trees are too big. These trees are probably too close to the dam and getting too big as well. So these trees should all be removed. But look at the vegetation. The vegetation's doing a wonderful job, right? Overtopping, and we're not really seeing a lot of erosion at this point because the velocity of the water is just not enough to start to cut down through the vegetative mat and start to erode the embankment. So having that grass cover, a nice, consistent, well-established grass cover certainly is an advantage as well.
So far, what we've done is shown you some of the issues, right? And I imagine all of you have experienced some of these to some degree, and if you haven't, you will, if you manage or operate or own a dam. So what we're going to do is run through a bunch of things about how do we maintain these things and what are some best practices, and go through some case studies. There we go. So lots of practice guidance out there. I actually really like the dike maintenance one, the one on the far left. So you can pull that off the BC website. Lots of good overlapping information. The one in the middle, I think, is from Oklahoma. ASDSO is awesome for resources, and you've seen some FERC guidance documents and some past ones. Lots of stuff out there. We're going to try to boil it all down to a couple takeaways and rules of thumb. But here we go. So vegetation best practice guidance. Embankments, areas adjacent to spillway structures, vegetated channels, and other areas associated with the dam, they're going to always require ongoing vegetation maintenance. So, whether it be mowing, grass cutting, removal of woody debris, these are all going to be necessary things. And remember, at the very start, a responsibility as the license holder, you're required to do these things. And we're going to talk about how far that requirement allows you to just go ahead and do stuff. So all embankment slopes and vegetated earth spillways should be mowed at least twice a year is a really good recommendation. Depending on where you're located in BC, you're going to have quite a difference in variation in your growth and type of vegetation. and we'll talk about that a little bit. But definitely at least once a year, and certain times a year too is a great time to burn things, and we'll see some photos about that. So here's some rules of thumb. So vegetation, keep it to 1 foot. So if your area doesn't grow very quickly, maybe one time a year is great, but maybe you got to do it 3 times a year. So consider that. So another one is shrubs. Dwayne pointed out some photographs where you've got some bigger shrubs, vegetation, trees. I mean, and we're going to talk about what do you do once you got a 3-foot diameter tree there, or what if it's a 6-inch diameter tree? What do you do? We'll get to that, but cut everything off at the bottom, and don't let it get over about a thumb's width. And then you can, take care of it with a bush hog or whatever it is. And maybe you want to regrade some things, and that will be typically under an approval, but so that you can easily mow it. So design and things are also, think about how you can make these things easily maintainable, and also keep a nice big area around it. We're going to show you a few examples, and we just say about a pickup length, 20 feet, 6 meters. And I'll bet most of the dams here today, if you think about your dams and all the interface areas, and looking at that little image at the bottom that I have my mouse at, do you actually have 6 feet all the way around? Oftentimes you'll have trees up to the, these edges, on the downstream slope all the way to the groin areas. We're going to talk about that. And
6 meters, not 6 feet. You want to?
I said 6 feet. 20 feet.
Yeah.
Or 6 meters. Now, so we need to manage the debris as well. I had a question about the log boom. Make sure they continue to be buoyant. Keep them connected. The photo on the right, I mean, it's not even connected. You might need to replace your anchors. The one on the left, is just tied around a tree, which could certainly work. In this case, they're replacing it. So here we see some log booms are, they're getting pretty tired. They're starting to sink. This is pretty typical. They may still work just fine, but you do want to stay on top of them. On the bottom left, that is a spec right out of, it's the BC plan submission guidelines for repairs or new dams. They put a spec right in there because they have so many questions. So, I mean, why not use it, right? And you can deviate from that. There are some people have better luck with slightly changed, but anyway, there's one that the BC guidance just gives you. So here's a photo of one recently in the Okanagan. You keep it like that. At a certain time of year, you might be out. It'd be easy to sweep it all off, and I'll show you an example of that in a second. Here's a dam, a pretty small dam that has quite a large spillway off to the left. The next photo is going to show that. So there's the log boom in the spillway. You can still see some debris getting into the spillway. There's some maintenance required. You can see a lot of debris loading in the reservoir. And here's another thing, log booms, do you even need one? We had 1 or 2 people say, never, I never have any debris. So why have a log boom? If you don't have any debris in your dam and you don't have any potential sources for debris in your dam, you probably don't need a log boom. And some spillways are designed to handle debris so that they're, I wouldn't call them maintenance free, but they have limited maintenance. But if you have a dam like this, where you have quite a large spillway that can be impacted by debris and you have a lot of debris loading, you have to stay on top of your log booms. So, and if you've got a log boom and you're using that water in your dam, perfect time of the year in the fall to pick up all that stuff. And you can see this photo here, right? They carried all the debris over there. You can see it wasn't from that year. It's dried out quite a bit. It's probably ready for burning. In this particular case, they have quite a bit of vegetation, though they also need to manage. But the examples just to show you, and that's why you want your OMS manual, because you can think about these things critically and think, how can we make this really simple and stay on top of this stuff? And we're going to try to hammer it in over and over. Maintenance avoids hefty repair. So there's a picture of, I think, a nice log boom. Anyway, they're all floating nicely. There are also some synthetic ones that work really well. Dwayne, did you have a point there?
Well, yeah, you can see very clearly that another benefit from a log boom would be erosion reduction on your dam.
Yes.
So there's only a light riffles and waves here, but that's a additional benefit of a log boom. It'll knock the wave energy down and minimize your loss of riprap on your embankment.
Absolutely. And this one has quite a large spillway off to the left. I think it's designed for like 80 cubes or something. So it's got a pretty good sized spillway there. And probably has quite a bit of debris loading. So we're going to show a quick example about, okay, so we've got this spec in the BC guidance. We might even be able to just put it in, just don't put it in like this. Okay, so question, what is wrong with this log boom? And you can chime in with questions to me, but I want you to think about it for a second. This is what it looks like. I can flip it back again to see it. So we've got, it's a pretty high alpine, subalpine lake. We've got a small little earth dam. We have a channel going across there to the low level outlet. Again, please feel free to chime in with a chat comment to myself or everyone. And we've got that log boom right there. So what's wrong with this log boom? I'll jump back up for a second. What does this thing look like? Someone said here, it is still considered best practice to have the log boom close to the dam when the dam is located in a stream channel below the impounded lake. Like a question, right? Is it a good practice? Or would it be better placed further upstream in the lake? That's a great question. Too far into spillway. So we have two people that have answered already correctly. Here we're going to jump on. Wrong location, should be further south. Exactly right. Where's the likely buildup location for debris? Right there. Exactly where we don't want peat bogs, all the stuff. And we'll talk about beavers as well. Just like that. And sometimes it's just stepping back and saying, what should it look like? Because sometimes we take these things over. It might have been, past generation. We got this dam passed down to us, or a new position, and we just carry on. This should be changed. This should be like this, and everyone was right on top of that. And really simple, low-hanging fruit. You do this, and it makes maintenance and also safety much improved. So we're going to keep going. Peat mat removal. Here's a photo of a 2019 inspection, and I noted it, and well, it might have floated away, but I'm pretty sure they pulled it out. So peat mats move around the reservoir, remove them when convenient, because they are not convenient. When that water is flowing and you're in an emergency situation, you're not going to be able to move that thing or get a piece of equipment in there. So stay on top of this stuff.
I go back to that one. That the looks like we've got alder growing there. Perhaps it's probably starting to get bigger than your thumb.
Yeah, right? yeah, exactly, right.
So in the background, that's the dam, and that stuff should be probably taken out about now.
Absolutely, right.
And of course, the darn stuff is going to grow right back. So you have to just keep mowing the shrubs down. Yeah,
in this photo too, you can almost see the sign. I don't know if you can see my mouse there, but that's the dam safety sign, and the spillway is right here, and it goes out the other way. And so had that got past the log boom, it's going to go around that corner. It's quite a narrow concrete control section. If that plugged that up, that would be enough to take out a good amount of its capacity. So anyway, it's doing what it's supposed to do. But once it does, you need to still take the debris out. Otherwise, you're not helping yourself. That loading will break your boom, and then your boom might be part of the debris going in. So anyway, Dwayne, I think this next.
And you can see how they've used a lock block at the end of this boom. That's their anchor, right?
Yeah, and I think that's right in the simplified BC spec too. So for a lot of these small dams we're talking about, where we don't have to think about big ice loading calculations and different hydrotechnical stuff, we could probably just adopt some of these simple booms.
Okay. So I'll take over for a little bit here. So here's an example. So there was a low-level outlet down underneath here, and as you can kind of see, most of the debris here is probably cattails, and probably muskrat is causing the biggest problem. So there's a lot of cattails been floating along and getting stuck in this thing. So they've They're trying to keep it clear. They're jury rig different ways to make it a little bit easier to pull the debris out. And you can get a sense that the water level on top of the stem, which is right here, there's not a lot of freeboard. It's probably less than that desired 1 meter, minimum 1 meter that we should have. And so, maintenance is kind of critical here when you're battling vegetation and muskrat activity. Not the greatest photographs, but it's before and after. So you can see how, the vegetation, the shrubs primarily, but some trees at the very far end were getting out of control, and they've cleaned the whole thing up. And when your dam looks like a dam, you're doing a good job. If you can see the whole thing and do your quick inspections, you've done a good job. Of course, you can get a sense in this far corner where these larger trees were. They were taking out root balls, and there's a strategy for doing that. And then they have to reconstruct the dam at that location. It's not simply chopping down the vegetation. So it's a lot more effort involved, and you're probably needing permission to do that from your dam safety officer. So we kind of scoured the various guidelines for tree removal, and here they are kind of summarized. And it's interesting. So the guidelines out there kind of distinguish between the upstream part of your embankment, the crest area, and the downstream embankment in terms of different strategies to deal with trees. If you've inherited, let's say you've inherited a dam that's poorly maintained, and what do you do about it? So, upstream embankment, they're saying get rid of all the trees, stumps, and root balls. And you're going to have to then clean out the root ball cavity and backfill with compacted soil of the right grain size distribution. The crest, if it's less than 12 inches, cut them flush with the ground. They were recommending leaving trying to prevent the decay. So prolong the decay so that the roots stay in that crest area for a much longer period of time, because it's the roots when they rot out that ends up causing the problem. And of course, if they're really big trees, they want them gone completely and the root ball filled. And then downstream, it's a slightly different diameter. This is at the stump diameter. You cut them flush with the ground or remove them. So that's your strategy. Either you're cutting them off and kind of walking away from it somewhat, or you have to start to excavate the whole root ball. And really your goal is to never get trees this big in the first place, so you can just deal with the much cheaper, easier removal by cutting the trees. Here's an example where you can see this business of that 6 meters, 20 feet, and maybe they've pushed out further than that. Any trees near the toe of your dam and roughly 6 meters beyond should be removed. So it's not just on the embankment itself, but you got to go a little bit beyond the dam in terms of your tree removal. Because things can happen down here, like you see some water. What's all this extra seepage coming from? If you have all the vegetation down there, you might not be able to even notice that, and things may be changing over time. And your dam is slowly walking towards a internal erosion failure mode, and you may not know it because you couldn't see it. And we're going to show you some examples of that.
And Dwayne, I'll give some context to this photo. This was from a colleague of ours, and I believe it was in Washington. But if you can see the trees way down, imagine those trees growing, like the bottom root ball of the trees coming only maybe 10 feet from the crest. You can even see all the needle deposits still all the way right up to the crest. It had only historically been inspected from the top, and then they had some seepage issues, and I think there might have even been seepage going into a neighboring property. But they're like, oh man. And so once they cleared all this out, I mean, look how visible that is. A photograph from that same perspective, you'd see nothing. Like
when the trees are this thick, yeah.
So anyway, just a little bit of perspective there. And that last slide there, if there's a slide to print screen and take home, that guidance there just to cut off, that's some really useful stuff. And we're going to talk about, where you need a notification or an approval, and show you some case studies about how to just put this into action and do it. So
Okay, good. Again, sort of extending on that, acceptable methods to remove the brush. You can use mega weed whips or power brush cutters or mowers. Stumps. If you have your upstream surface of your dam has riprap on it, it's hard to work around the riprap to cut things down really close to the embankment because you're dealing with all the rock. So you cut them as close as you can. This guideline says to chemically treat these stumps so they will not form new sprouts. Aaron and I struggled to find any guidance as to what chemicals are allowed for that purpose. And so there's room for, I guess, dam safety section in this province, or as far as even in the country, to come up with some better guidelines for what are we allowed to use, because you're on the if you're in the riprap, you're on the upstream surface, and so you're very close to the water, and you're not allowed to put any herbicides into water typically. And we're at a loss if any of you have had personal experience about some chemical that you were given permission to use. Definitely slide that into the chat because we would learn from that ourselves. Small stumps, if they're relatively small, you just leave them in place. If they're bigger, your best strategy is to entirely remove them, including the root ball. You could pull them out, grind them down. The removal of a large root ball requires usually a significant excavation into the embankment, and that triggers an approval process from your dam safety officer. So really your goal is to never get to big root balls because you don't have to ask for any approval. You're fully got free reign to deal with maintenance of the smaller shrubs and trees before they get too large. If, however, you do have a large tree, here's kind of a bit of the guidance. So the tree gets cut off, but now you're dealing with that root ball. And the strategy is to completely excavate it and gathering up most of the big roots. And you end up creating this is roughly drawn to scale, I guess, a relatively large hole in your embankment. So you have to do this at a time when the reservoir level is probably going to be low, and you want to do it fairly quickly, and you want to have the right soils to put back in, and you need to keep this fairly steep. So a 1-to-1 slope on that excavation means that soil will be quasi-stable, and you don't want to leave it exposed for very long. So you dig this out and you start layering in soil, probably in about 8-inch lift thicknesses, each of those layers compacted. And this little red is kind of to show you that you need to kind of step those layers into the existing embankment. This is the existing dam over here, so that you have a good compaction and a good fit between the existing embankment and your new soil. So this all takes a little bit of time and effort and care, and it's going to cost you something in terms of money just to do this. And if you can avoid this by making sure that tree never got that big in the first place, that's the best strategy. Another example, if you look there's a person walking along the crest of the dam. And we don't have very large trees on here. Some of these might be too close to the dam over here in the background. But there's those alders again and other vegetation. So that's violating that rule of thumb for 1 thick high, because you can't really see anything on that embankment. So it's an area where things grow really well. And once it's this thick, you just can't see what the dam's doing. Conversely, on the other side, look at that thing. That's gorgeous. What a beautiful dam. It's just grass and grass only. I mean, if you have a dam that looks like that, please send us a picture because we almost never see them. But there's kind of the highest level of care and maintenance, keeping this thing really tidy and neat. Some more examples. So here again, it's largely grasses, which is good, but again, it's really hard to see anything because they haven't been mowed down, or or they don't have cattle in the area that help the mowing down or whatever. It's thick and a bit high. Over here, some of these shrubs have been probably knocked down. You see a huge pile of organic material. Aaron, where did that come from? Do you know?
I do. Which one? On the one on the left?
Yeah, that pile of organic material that's sitting up by that vehicle on the crest.
The vehicle on the crest. Oh, yeah. I do recall where that was. Yeah. It was in sort of North Okanagan area.
But where was the material? Where did it come from?
Oh, well, the vegetation, they got a spillway over to the left side. That kind of heads around and joins up to that low-level outlet.
Was that debris in the spillway?
And on the upstream bank. And they actually have, similar to what we showed as a better guidance, to have a point in the reservoir where the, kind of does a V on your log boom. They would have it typically on the sides of the V, right, where we showed where that vegetation was.
All that floating vegetation concentrated in that one area, and they pulled it out ready to dispose of it or burn it.
And really, the center of your dam is often a great place to burn, right? Because it's away from those interface areas, right? And you've got a lot of room for a safe burning area, and you wait till, off season where you can slash burn.
Okay. Here's a before and after shot of a small spillway. So the dam is behind the person taking the photograph, and there was vegetation in here getting a little bit thick. They've removed about most of that vegetation, including some other logs and debris, just to open that up a little bit so that the spillway is there. When you need it, you want to make sure it has full capacity so that your dam doesn't get overtopped. And so this is basically showing that sometimes you need to start to do vegetation management at quite some distance beyond the embankment part of your dam, because your spillway structure could go downstream some distance, as it does in this photograph. And here's another example. It's a diversion ditch linked into a storage reservoir, but it's when it gets really filled in with willows and alder and birch and poplar and other trees, to come in there with a big weed eater and clean it out does a really good job. So you go from totally overgrown to something where it's really easy to inspect, and you've got full capacity of drainage capacity in that ditch. Oops. Well, we've already talked about it. Vegetation, it's not all bad. And so yet again, a really good example of a well-maintained dam. Look at that dam, gorgeous, just covered with mowed grass. It's easy to see, easy to access. You can see they've been pulling out debris that's been acquired probably at a higher water level. The reservoir's back down now. So that they can go and manage and get rid of this debris. This is probably suggesting they don't have a boom on this particular dam. But looking at the dam itself, that's what it needs to look like. You can see in the groin area over here, they push the vegetation back far away from the dam, so you can see the whole thing. It's easy to inspect. It's easy to detect deficiencies in that dam if there's slumping or seepage. And I think this is my last, or almost my last example. So here's the downstream face of a dam, and you kind of, there's a few little shrubs here growing. They're not of any substantive size at this point because they're smaller than the thumb. They can just leave them be. But you can see where we're sort of standing here, and where this probe is pushed into the embankment, and there's water sitting right there. Where you have a pretty dry, arid environment on your dam, and suddenly you start to see things growing, it's an indicator that you do have water in the embankment, and perhaps seepage and maybe an elevated water table through your dam. And so the vegetation is now being, you can use it as essentially instrumentation to indicate where there are wet areas on your dam, and that's going to require a more careful inspection of those areas on a go-forward basis. So here, the wet is by these. I'm not a grass expert, but these types of grasses, if it was lower, if the wet area is lower down, we often end up seeing cattails grow in those environments. And one more example. So this is near a low-level outlet, and above the low-level outlet, you can easily see that the vegetation just pops up and is taller and more vibrant. So there's been seepage through the embankment above the low-level outlet, and you can use the vegetation to really pick that up. Okay, back to you, Aaron.
Okay, so we're going to go through two quick case studies. I'll try to go pretty quickly here so everyone has a minute to run to the washroom. We're asking questions. So this one's about obscuring your view, right? You see a photo from a fall 2019 inspection. This is on the downstream slope. Remember that picture of a pickup, right? 20 feet from embankment. We see this embankment actually extends right into the tree line. You don't really have a clear interface area. Same area, walking around, you see that's actually a photo of quite a bit of diggings, right? Or like cutting a burrow, right? Where they dig down and pull the material out of the embankment. So lots of little things like that was found in this particular case, excessive seepage, a number of things. So the photo on the left, basically I'm standing in the middle of the downstream slope. So looking toward the way the water flows, I look to my left, there's a tow seepage pond. So, and you can see quite a bit of vegetation growth there. It's quite wet, soppy, so you get a lot more aquatic type vegetation growing there. And then you turn to the right, I'm kind of standing in vegetation, trying to look and find things. There's actually a larger tow pond that's obscured from the view on the right side. Essentially, the one on the left flows to the one on the right. They do measure seepage and they do quite a bit of manual inspection, walking up and down these. And you know, you can see it's quite
hard to do inspection with that much vegetation, though, isn't it?
Well, and that's just it. And so my inspection found quite a few things and quite a bit of seepage, and identified that this is a potential seepage area that is of concern. And we'll talk a lot about backward erosion, types of erosion in the next webinar. But the client there took that advice and was like, I'm going to keep on top and keep looking at this. And this is what he found. So I'm going to show this video. And what he found was, can everyone see that? Mine's jumping just a little bit.
Yep, I see it.
Yeah.
Play it again.
I'll play it a few times. I almost got like, you know, low frame rate, but what it is the water's coming up and it's actually flowing and creating a boil. So, you know, it could be pulling material from out of the foundation, or maybe it's just moving water right at the exit. But the whole tow area has quite a bit of seepage. And here we see that it's gotten to a point at which that seepage is able to start to erode that tow, almost like a backward erosion. It starts from downstream to upstream, like a pipe. It starts to erode a pipe and then the water finds it. So hats off to the operator in this situation. I'm going to show you the line at which the vegetation was, but that's me in the blue hat there. And that's the operator, one of the representatives for the dam, and he's helping me install some monitoring equipment. But where I'm standing there was probably 10 to 15 feet of brush, and it extended back. You can see some of it is all hacked down and laid down. So for him to find this, he would have had to been almost in, you know, certainly ankle deep of water. And this is typically what it does require to inspect these dams. Is to do, and that's why we do one thorough inspection. It's not just a longer form we quickly fill out. You really want to look for these things, because this, if unintended, you're not out there for another month, depending on your consequence, that could be all it takes.
Aaron, just
yep.
So people are really clear, we that water you see is not the reservoir. This is downstream. We're looking downstream.
Yes.
So that
Go ahead,
that
Wayne.
water that was boiling is essentially where that gentleman is bent over. So right at the downstream toe of the dam, buried in a whole bunch of vegetation, but the guy found it, fortunately.
Yes, yes, he did find it. So I'm just going to go to the next slide here. So I just lost some of my functionality here. Apologies. Dwayne, can you give me the next slide there?
Yep.
Oh, back one.
Okay.
So there's the line of
Well,
the bit.
so the view we're looking at is the
That
toe.
one there. Yes, perfect. So what we have to do is go in and do a rapid. Basically, we monitor it for a couple weeks, and we were really worried about it running away from us. So we did a rapid conventional filter, essentially blanket filter, and repaired this thing. So they have some increased monitoring and other things, and you can see we talked about that screenshot. I said if you're going to screenshot something, we said on the downstream slopes and not the crest area, anything bigger than 8 inches cut off. So you see some pretty big stuff cut off. Mind you, this isn't in the embankment, but we're in that interface area, right? We're in that within that 6-meter buffer. So could there be problems down the road? Certainly possible. It's an area of attention, and it's actually undergoing further analysis and other work. But it's just to demonstrate that some of these issues, maybe it was even affected by vegetation, but vegetation certainly played the part where it obscured the inspection, and they did manage to still find it. So, but it could have been much worse. Dwayne, could you show the next slide? So that one shows the edge of the forested vegetation, and you can see it's quite substantial. So, and where that person is standing is about where it was found. So it was well into the brush.
So in this one, they were doing a pretty good job of keeping the vegetation off the rest of the dam, but that one little spot is they weren't. Like
right.
we're basically where that person is bent over right now is kind of close to where that boil was occurring, but it was hidden in a lot of vegetation.
We talked about these already. Remove the vegetation. It's going to improve and aid with your deficiency detection. And remember, the downstream slope is going to have a higher phreatic surface. You're going to have that seepage coming out, an area that's of high concern for potential burrows and shortened seepage paths. So we're going to be talking about a lot of that more in a second. So case 2, they have this channel to take all the seepage away. So this photo is taken in spring of 2014. So small diameter trees cut off at the base typically doesn't require any DSO approval, right? That's easy. This is now hard, right? Because okay, well, we cut them off, but these are clearly in the embankment. So how do we approach this? So what the client did was they went ahead and had a planned removal plan, when the water's down. Not easy. This particular case would require approval. So this is 2014 construction. I asked, is there anything wrong with this picture? Dwayne showed an image of the downstream slope and showed how you kind of have to step it. FERC guidance, I think, is like a 3-to-1. But typically, you want to have a plan design about how to do this to avoid differential sediment and other potential issues in future. So this not only became a much bigger job than cutting and removing and just maintaining vegetation, but it became quite a substantial repair, and it even got worse than that. So this is after construction. I mean, it looks so different than the first photo. I mean, even the road now is all just cleared. The following spring, we have major seepage, some slumping, internal erosion identified. It ended up becoming an emergency. I wasn't involved in any of this. So they had to draw the reservoir down and so on and so forth. They did end up having to do a design filter repair, and so they installed the filter, and it ended up being bigger than the first job. So the case 2, the takeaway is remove vegetation regularly. It's simple. It's a cost-effective way to avoid expensive repairs in the future. Vegetation maintenance improves surveillance, aids deficiency detection. We've already said that. So again and again, we want to reiterate that. When any dam excavation is required, it is important to plan and execute repairs properly. So get involved with an engineer, submit those applications. I actually had a question on the chat was, do these larger trees require an engineer? And unfortunately it does, because it's gotten too far and now it's going to be too expensive. So that's the end of that case study. So Dwayne, you have a poll. We'll have to.
Yeah, I've got one more poll just to keep everybody awake. It's simple, 2 questions.
And it'll be interesting to see what animal issues people have as we dive into animals for the second half. And someone provided some information to me on the chat about, Dwayne, your question about what products could be used on vegetation.
Oh.
And they mentioned Habitat Aqua. And they also said, let's see, that one was you could use for species like knotweed. They had a link here. They also, and someone else said a high percentage vinegar mixture with water can also be used to treat on different shrubs and weeds.
50% of the people never have animal problems. I guess lucky them.
Yes.
And the other 50% are dealing with, looks like both muskrats and beavers. Okay, I'll start. So there are guidelines for, just like there are for vegetation, there's guidelines for how to manage wildlife on dams. But let's take a look at what we're trying to watch for and why we care. And it's typically burrows. And so there's a lot of different species, rodents especially, that like to burrow into our embankments. And so, you know, on the upstream side, it might be beavers or muskrats. On the downstream side, it could be, who knows, marmots or badgers, or all sorts of different things can burrow into your embankment. If they do that, and let's say the worst case scenario, they kind of do it almost on the same cross section of your embankment, you get this situation where, you know, before the burrows, this is your embankment, and water trying to seep through it kind of fall. This is kind of the top of the water table, if you think of that, through the embankment. You put a burrow through, and all this water comes over to here, and it may rise up higher here. And as that water table rises up through your embankment becomes less stable, and there is a higher chance, particularly in this burrow, to initiate some piping. And if you start to see water coming out of this burrow carrying soil, you've got a real concern on your hand. So if we can try to prevent or repair burrows, we can maintain the integrity of the dam. And there's guidelines about, you know, what are the important areas to watch for, and so critical areas to inspect for animals. So it's this area here on the upstream, of course, because it matches the previous concept, and here down in the downstream toe area. So wildlife burrowing into your embankment down on the toe and up and at the upstream crest area are the critical areas. If they're burrowing up in here, where my mouse is moving, kind of on the downstream crest area, not so critical, because the seepage tends to never be up that high anyways. And so some things, you know, I'm not a muskrat or beaver expert here. Some of you listening might know a lot more about that than I, but, you know, muskrats are, they tend to favor a steeper slope to tunnel through. And so if you have a very gentle upstream slope on your embankment, it'll be less attractive for muskrats to start digging holes into the embankment. Mm-hmm. Of course, you know, muskrats typically will go, their burrow starts under the water level. And of course, in dams, our water levels are usually up and down, but they like to start under and then they climb back up further above the water level for their dens. So, you know, the guidance, if you went for a more gentle slope, this burrow that's shown here is probably a lot less likely to actually occur, because the muskrat doesn't like that kind of geometry for their burrows. So that's one strategy. If you're dealing with muskrats all the time, it's a real problem. And if you're building a dam or repairing a dam, maybe flatten that slope. So here it's a 3-to-1 slope. Of course, beavers like to block spillways because they get excited about the ability to block a spillway and raise up the reservoir level. And what are you doing here? Well, you're likely to be simply removing the blockage, and it would be much better to remove it before it even gets to either of these photographs. So a much smaller stage as you just start putting the sticks in there. I think at that point, you don't really need any permission to remove the debris. It's debris as opposed to a beaver dam at that point. And if you have, conduits through your structure, beavers can make a real mess inside of these things. And so here's a couple of examples. And it takes a fair bit of effort to remove all that debris once it gets really packed in there, the organic material, and the beavers will haul in rocks and soil as well. And beavers can burrow. They do like to burrow, and again, they're typically starting near the water level or even slightly below it as they make their tunnels. And of course, the beaver tunnel is quite a bit larger than a muskrat tunnel. And these are examples on an embankment. And so, you get kind of concerned when you see a big hole going through your embankment. And some examples of where these burrows have collapsed. So there's, they collapsed all the way up to the stake. I think that's the same stake here. And you can get a sense that high water level was where all this bit of line of weeds and sticks and debris is. So this whole thing is now collapsed. And the question is, how much further does this thing go through? Fortunately, in this case, the burrow was kind of almost parallel to the embankment surface. It's kind of going parallel up the embankment. But if you have a burrow going in more horizontal, it's a bit worrisome. And other rodents, they like to make homes around things in your dam. So even if you have drains around your dam, they look at this as an opportunity to have a nice, somewhat protected entrance. And so you're looking for other rodents, and these will typically occur on the downstream face of your dam. So on this picture on the left, water's down here, so they're above the water a little bit, but here's a bunch of holes. These are photographs I took last fall on the downstream face of a dam. And if you got some coarser material, they tend to like to use it as a way to kind of dive under and have a kind of protected entrance. And muskrats, they make their burrows, and those burrows can collapse. So here's some examples of muskrat damage to embankments, and more of them. Some people have done some interesting things. They've injected kind of a foam into burrows, and then they've carefully excavated around the burrows to see what's the pattern. What do these things do inside the embankment? Like how big can they be? So this is what you're looking at. Everything that's kind of sprayed is kind of this foam that was set up inside the burrows, and they kind of excavated very gently around it to see what the pattern, what was a network of burrows. And as you can see here, it's quite extensive. So it might surprise you that the muskrat can make such a large network, and how far back into the embankment a burrow could go. And this is not the greatest photograph, but burrows are starting here, and the collapse is occurring way over here, because these burrows, this is in a dike situation, went a very long distance into the embankment. One little tidbit of information, and I think it's borne by my personal experience. So muskrats prefer to build their burrows where no waves occur. So this little image here is showing the wind direction at Dawson Creek. So the dominant winds, especially at the higher velocities, are almost due west, coming from the due west. So if you have let's say a dugout, that's the easiest analogy. So a dugout where the embankment makes a complete ring. On the very west side of that dugout, you will not have very high waves. On the east side of the dugout, because the winds comes from the west and it picks up the waves as it goes across, the waves build as it goes across the dugout, you will have higher waves. So if you're looking for muskrats, you're going to find them on the west side, not on the east side, because muskrats prefer to build where the least wave height occurs. And when I was a kid, I used to run a trap line for muskrats, and I never knew this at the time, but I knew where the muskrat dens were, and they were always on the west side of these dugouts. This was up in the Peace River area where I lived as a kid. You know, we throw it in here, but you know, a lot of our agricultural dams are in areas where there's cattle, and the cattle can wander around. And so, you know, if you get a lot of cattle traffic or quad traffic or truck traffic, there's various ways that you can damage your embankment through footprints and the erosion that kind of is associated with that. And that's kind of a photograph of damage on a dam from cattle. I think that's back to you, Aaron.
Yeah, it is. And I got all my controls back, so it should go a little smoother now. Yeah, so that's the introduction to some of the impacts of animals. So what do we do about that, right? So we've got some slides and examples coming up here. I really like the DNRC guidance. So that's Montana, basically kind of like BC dam safety. It's the Montana one. They have a couple similar critters as we do, and they've published some prescriptive guidance. There's lots of other stuff out there, but we'll just give you an overview of some of it. So a lot of this stuff, again, is, you know, we've got trees that are a problem, some short and seepage passive, you've got rotted out roots and things, but you still have the same kind of approaches, right? A lot of this stuff you can do as just maintenance, right? You can fill in a little hole, you know. I think as a rule of thumb, as long as you're not excavating like with equipment, you're not really doing work on the dam. But anyways, you can always contact your DSO. But here's an area where they have quite a few muskrats living in there. I'll give you some more context in a bit. But so this is, a lot of you will have dams like this with an upstream slide gate. You'll have some kind of a valve stem, at least this one does. This one also has a concrete support. It's on the upstream. In this case, there is a little bit of wave action and a little bit of steepening, but it's a pretty protected reservoir. There's not that much wave action, but there's quite a few muskrats in the area, at least one in particular that was quite problematic. But, you know, you have that little bit of a bench. Dwayne mentioned you have, you know, maybe a rock or something that it can hide behind. Naturally, this ends up being the perfect place for a muskrat to set up. This case, you know, you kind of see the opening of the muskrat hole is a little bit eroded, but what they had done is they kept digging under and getting underneath that concrete support. So it didn't extend very far, maybe just a few feet. And so this one could be filled in. In this particular case, you could do this type of work without any notification or approval. You could fill that in with some embankment or similar material to your embankment, and maybe put some mesh over it to keep it from happening again. In this particular case, they knew someone who was a trapper in the area, and that's how they were able to deal with that. So they didn't actually have to do anything. Someone that already, you know, was in that sort of business.
So Aaron, in this photograph, the reservoir level's been lowered a little bit to aid the maintenance.
Yeah, and this particular dam is an agricultural dam, at least right now, and still it has agricultural use on its license, so they can raise and lower the water. In this particular case, we were already doing a bunch of other work on this dam as well as another one on the reservoir. So it was already drawn down. And while it was drawn down, here's the other thing is just because you're doing things as maintenance doesn't mean you don't want to still implement best practices. It's so easy to put in some silt fencing. You're still going to get some runoff in any disturbed areas. If you're putting fresh material down, you can still isolate those areas to keep sediment and other things moving. We didn't mention it when we were in the vegetation, but just because you can go and cut the vegetation off, we were saying anything less than 8 inches on the downstream slope, or maybe 12 inches on the crest or interface areas. You still want to consider nesting birds. There's, times of the year where you can optimize that, and same with the with fisheries, right? If you do have to get approval to do work in and about a stream, you still want to consider fisheries and how you're going to affect habitat. So anyway, just a little overlap there. We'll get into that a little bit more. So in this case, we just filled it in. I said we were already on site, we already had material and equipment, so it was just an easy thing. In this case, they dealt with the muskrat by sort of making a deal with the local trapper. But you can also, install mesh or deter, right? The idea is to avoid conflict wherever possible. And oftentimes it just requires a little bit of filling in. So burrow was shallow and erosion was limited, so voids could be easily backfilled and regrading. Since no excavation occurred, it fell under maintenance, right? And also because they were able to draw down that reservoir. So, so when you see these things, how do you know how big they are, right? Just a little steel rod and another welded. We had someone say, was the area seeded? I would say not yet, but there is a seed spec in that work, and they had 2 options before it snowed or in the spring, because we had other work happening. So in the spring, they're going to do it right when the snow comes off. And I have another photo from that same site, and you'll see snows everywhere. We're not quite done. But maintenance for muskrats, you walk around with a probe. Probe is a great way to look for areas of low density or voids. If you see one of those, poke around above. You might puncture through, right, and find this thing. And if you do and you determine it's small, then you can go ahead and fill it in. So mud packing is a recommended method. We're just going to steal my mouse there. So mud packing is a general backfilling procedure using a mixture of native embankment material. So you could take it from a borrow, or maybe you have some material from the dam there that's already been dug out. So 9 to 1. So you add a little bit of cement, and you mix that and wet it until it's almost like a high slump concrete. It's pretty messy work, to be honest. But then you can take like a riser pipe, like say stove pipe or whatever you got laying around, maybe 3 to 5 feet to give it some head or some pressure, and with a shovel. And again, as long as you're not really excavating into the dam, if you're doing just a little bit of shovel work, filling, you can do all this stuff and do it quickly before it becomes a problem. And you can open that up and sort of fill it all in. So, and they say too, you don't really want this mud pack on the top. So, where you have access and you can get some good compaction, fill it in with the embankment material, preferably moisture controlled, and get some good compaction on it. And seed all disturbed areas. And that goes back to that other question, was the area seeded? So rule of thumb, if it's less than about a meter, and it can be all done with hand tools. This is kind of like weeding removing vegetation on a small scale. You can go ahead and do that. And again, this is our opinion. And if you're ever kind of in a gray area, you can always talk to your dam safety officer. We're going to have their contacts at the end of this webinar, and they're a great resource. You can always just call them and ask them, and then you get the straight goods for your particular case. So beavers too are often problematic. I'll give you a quick little backstory. This is a very small, very low head dam. It had kind of a undersized spillway. The low level outlet was very close to surface. It completely dries out in summertime. You can walk across the reservoir, it gets quite vegetated, but also a very the beavers love this area. So they were having a problem with the low level outlet, and there's quite a bit of debris around. I'll be honest, this dam was not well maintained. They knew they had to do quite a bit of work on it, keep it so it's not a beaver problem area, but they couldn't bring the reservoir level down because there's debris. And then other times of the year that they'd set up in there and have set up around the reservoir, and we found quite a bit of debris in there. We think some of that debris was dragged over by the beaver, and there were certainly other beaver attempts in the spillway to fill it up. So, I mean, this is what we ended up finding. In this particular case, it wasn't very easy to get debris out of the low-level outlet. This one ended up being quite an extensive repair once it ended up becoming a full spillway redesign. The embankment was mostly reconstructed, new low-level outlet works and other things. Oops, I'm trying to get to the next slide there. So again, the idea is prevention. Where possible, we talked about a 3-to-1 slope to deter muskrats. It's also a stability guideline in BC, 2-to-1 minimum downstream, 3-to-1 upstream. So that's really good guidance. Also having things, trash racks that also serve a purpose as kind of beaver blockers. There's other, for smaller dams, there's different perforated pipe type designs. So it really depends on what your application is and also what your flow requirements are, what works. And even sometimes these big trash racks, they work quite well for slide gates. There's lots of examples, lots of design guidance. So we mentioned the Wildlife Act. You can get an exemption from the Wildlife Act, but we want you all to know that it exists. If a person commits an offense, by disturbing, molests, or destroys, it could be a muskrat den, even though the reg says beavers, that could be a muskrat den or a beaver house or den or beaver dam. Really anything that affects the habitat and their ability really to survive is protected. And the same goes for fish. The same goes for other habitat, right? We mentioned birds and removal of trees. So whenever you're doing extensive work, that's why they want these approvals. They want to make sure that there's been some consideration of these regulations, and that things like controlling sediment or avoiding mortality of fish and so on ends up becoming a thing. So the beavers are certainly protected. There is some interim practice coming out from federal guidance as well. So similar to fish, regulations that are not provincial, we do need to be cognizant of those. So who knows, maybe they're going to have some practice code coming out and maybe some regulatory guidance that will apply here as well. So, beaver management, focus on prevention. So always prevention first, but we all know that sometimes, prevention doesn't always work. And sometimes there is a balance that needs to be struck and something needs to be done. So if removal is required, and this is from this document, and this document is not their newest document out, but it's the most clear guidance. And it's also referenced in a recent permit that I'm going to give you an example of. But if you have continual work that you need to do on your dams, you have diversions and other things that are part of your dam works, you can get exemptions and be able to have some rights to deal with them. So here's some guidance in the document that's referenced: is you must have landowner permission, you must notify Ministry of Removal or conduct the work as part of an approval, so which has the details described in there, and be prepared to supply supporting documentation. So we talked about, why an environmental management plan or recommendations or maybe even monitoring might need to be submitted with a request for a permit. So here's an example of a permit. This one, it's a 5-year permit. So it's a permit for beaver dam removal. And the problem is in this particular case, they have a network of quite a few diversion ditches and as well as the dam. So you might be on top of your dam and your spillway, and you keep getting the sticks and be on top of it more than the beaver, but there are situations where you can't, right? You know, you might have kilometers of diversions. I mean, they can set these up quite a bit quicker than you can inspect them. So in this particular case, it gives quite a bit of guidance. It had documents attached, including environmental management plans and so on, how to do it, how to be cognizant of fish, where they're allowed to do it and what times. And this particular one had a $500 fee. I think it also had a surcharge fee of $50. So to give you a sense of what may be required, if you need to go to those extents and you can't stay on top of it, and again, our takeaway this message is stay on top of the maintenance so you don't have to get into all these things. But if you're in a certain situations where maintenance isn't enough, there are ways to deal with beaver lodge removal or dam removal. So we're going to be wrapping up here in a few minutes and going to some questions. Dwayne, did you have a comment there?
Yeah, well, yeah, I want to make sure that people aren't too afraid of doing what's necessary to maintain safety of their dam, because as a dam owner and under your water license, you are obliged to make sure that thing remains safe.
Wow.
And
yes.
if, for example, that beaver dam is in your spillway and you have an atmospheric river, or you have a big spring freshet or something coming, you know it's coming. Maybe it's coming tomorrow. This is going back to that disclaimer at the very beginning of this webinar. I'm not going to wait for permission. I'm removing the dam, because if you lose that, removing the beaver dam in my spillway, because if you lose your dam, the consequences are vastly more significant than disturbing a little bit of beaver habitat. So I think we have, because the various regulations, you're obligated to look after your dam, but they're also saying you may need permission to disturb or remove a beaver dam. But if they all conspire at the same time, and public safety and environmental safety downstream of your dam is paramount, I think it trumps everything else. So just do the right thing and make sure your dam never fails.
Yeah, Dwayne, and I'd also point everyone's attention to last year's webinar 3 was emergency response. And we talked a lot about when something becomes an emergency. It can even be a level 0 emergency or a one, I think it is. Or even that seepage of that low, that boil. I mean, immediately we have a potential dam safety hazard, which falls in emergency category. If you're under an emergency, you have an approval to act because it's an emergency. So, but you need to realize too, it's a provincial approval to act. It's kind of like an order. So it doesn't exempt you from maybe other requirements that aren't covered by the Water Sustainability Act, like the Wildlife Act, or the Fisheries Act, which is federal, but you still need to do your best to implement these practices, right? And sometimes you have to strike a balance, and where safety ends up being paramount. And that's understood. And so we often get in those cases in emergency management where we're in freshet and we have to put an excavator into the water. And sometimes that's just the way it is. So Dwayne, I'm glad you mentioned that, because, you know, like the trees in the park, right? Things don't always nicely sit side by side. There's some conflict sometimes, and a balance does need to be struck, and sometimes it doesn't always. Yeah, it is what it is. So I'm going to keep going here. We're getting close to the end. Here's a quick. This is a repair of a muskrat, or there was some muskrat damage on this one as well. A lot of that cattle foot traffic, and I imagine a lot of your agricultural dams will see this. They manage it pretty well with some fencing, but as you can see, when the water level goes down, I mean, it's full access. So in this case, it needed to be reconstructed to a 3-to-1. The downstream slope was widened as well. So sometimes just time and degradation requires repair, but a lot of this could be avoided just by implementing simple best practices. So sorry, I went by 2 slides there. We talked about that repair, but if you have areas that are problematic with muskrats, well, you can also protect them with riprap or some meshing or something of that nature. Excuse me. And it also serves a dual purpose for the wave action. So I'll keep going here just to interest of time. The toe areas, Dwayne showed the zone 1, zone, I can't remember, it was 4, and I think that what came from some FERC design guidelines. But these are areas of critical that you really want to look for, because they can really impact that internal erosion. And internal erosion is roughly half of all dam failures. And this is where the rodents are really problematic, and the root bulb, if your tree gets torn out. So you have to repair it in a very similar manner as a large tree, root system removal, where you have to cut it. Again, we could probably almost draw on those little steps going down and how you need to step and compact that, but you could also put optional wire mesh replacement. So again, you just don't want them to get too large. When burrows are too large or difficult to repair by mud packing, or if they're in an area of concern, repair will require engineering plan and preparation of a development report to obtain a DSR approval. So if it's an area that you keep seeing stuff all the time anyway, maybe just lay some preventative mesh down now, and then that's it. Then you're done. This is actually the same dam that we had the little muskrat, bit of material filled in. This photo was taken before. We're going to talk a little bit about piezometers and stuff on Wednesday. This is some low-tech piezometers we were putting in. But this cobble was really problematic. You could see them, they sit up on the rock looking at you, and then they duck down behind there. I mean, you don't know what they're doing. And there was lots of little rodent holes and stuff in there. And you can't really poke around when you got a pile of that open graded riprap, and it really just doesn't help you in any way. So we don't recommend doing that. So with maintenance, is it maintenance or work? I think if you're moving just open rock, you could probably just remove it on maintenance. Definitely under a notification. You could just notify them, potentially an email and a photograph with a circle about what you're moving. In this case, after the work was done and part of some embankment repair and seismic stability work, we also put in some monitoring. And we're trying to introduce you a little bit of these things for Wednesday. Wednesday, we're going to move to all monitoring. It's going to be right. We're going to talk, it's going to be quite technical about, how to look at phreatic surface, pore water pressure, how to read piezometers and plot the stuff. Really interesting stuff. But in this case, look, you remove those boulders off, you can see where the burrows may be setting up. But also, if those burrows were there in the past, now you have an opportunity to maintain it with your eyes, visually. The vegetation's off, but now we're going to also move one step further to monitoring. You could install V-notch weirs, collection ditches and things. We're going to be talking about all this stuff next Wednesday. And I think that pretty much brings us to just about the end. And don't forget to record it. If you're audited by the DSO or you have your dam safety review, a lot of people say it didn't happen unless it has a record. So definitely record it. And when you do record something or find something on inspection or surveillance, follow it up. Excess vegetation, make sure that gets taken off annually. So as a summary, focus on maintenance so you can avoid costly repairs. And that really is our main takeaway. Dwayne, did you want to?
Well, just coming back to that recording, it's so easy to kind of, when you're busy,
over it.
Yeah, to ignore it and not do it. If you go right back to the very beginning of this webinar and the regulations, there's some language in the regulations about recording. And so best practices is to do the inspections, to do the maintenance, and hopefully you don't have to do repairs, so you don't have to do what we see on this slide.
Yeah.
So you're doing the maintenance, but record what you're doing, where you're doing it, when you did it. And that record becomes helpful for both you as an owner, but if anybody's reviewing, is brought in to do a dam safety review or review your operations, you've got that record, and that becomes really valuable information for them too. Because you might have noted that there was some seepage at some specific location in the past. Well, a person, an engineer that's hired to review, wants to know where that was and when it occurred, and what did you do about it. So recording
and how
is
much?
important.
How
Yeah.
much seepage?
Yeah, how
Right?
much?
Right. So, and we're going to get into a lot of that next week. Actually, I think next week's Wednesday will be my favorite webinar. There's quite a few fun stuff in there. I think
So we
everyone
have just a couple just a couple slides here. And so, we just want to remind you that your dam safety officer is a resource to help you and guide you. And if you have questions or you're uncertain about the proper protocols and paperwork and forms that you need, please reach out to your dam safety officer. And there, of course, there are webinars like this one and the ones we did last year, and probably there'll be other ones in the future. And there's lots of information on the net. The dam safety website, if you go to that website, you see there's in the middle of the slide, find educational resources. You can see our Aaron and my smiling faces on other webinars already posted in there. Plus lots of good guidance. So please take advantage of that. And just to acknowledge, and I hope I got everybody on here. These are your DSOs that are really responsible for the smaller dams in the various parts of this province. You probably know them already. Make sure you reach out to them if you have any questions. So thank you for spending 2 hours with us.